Hello, everybody. We're going to look at Saxon Math, Course 1. This is Lesson 108, called Transformations. In this lesson, we're going to find out that figures have the same shape and size are congruent. So the word congruent simply means that they have the same shape and the same size. One will fit exactly on top of the other. That's exactly on top, not just slightly. The matching parts are going to be equal in their measures. So for example here, you can see that triangle ABC and XYZ are almost exactly alike, except they aren't on top of each other, essentially. So number one, first step is you would have to rotate this shape, and that's one of the transformations that would be taking place, is a rotation. Step two would be to translate it, which means to slide it. Once you've rotated it, standing up on its edge, and we would slide it over to make it closer to this position. And our third step in this particular case would be a reflection. And in order to reflect that, then we would just flip it on one of its, in this case, the vertical axis. So there's three transformations that you can make: the rotation, translation, or reflection. And not always will you need to do all three of those. If you're to rotate something, you're just going to turn the figure about a certain point. So like in this case, we would rotate it around this corner point. If we were going to translate it, one of the things I remind myself, this S and L stand for slide. So translation is simply sliding a figure in one direction without turning the figure. So once we were to rotate this from its original position, all we had to do was slide it over to get it into this position, but then we weren't quite done yet. Then we had to do the reflection on top of that. Reflecting a figure as in the mirror or flipping is what you would do over a certain line. So here these are again. You have rotation, where you just turn an object. So if you were to turn this object, you would be rotating it. We also have translation, which is simply sliding an object. So if we were to take this triangle and slide it around, that's a translation, sliding it. And then reflection would be what happens if we were to take this triangle ABC here, and it's reflected into XYZ. You can see if we were to reflect it, it's on this line right here. It's a mirror image. So that's reflection. Let's look at some more examples here. So if we've got problems A through E, if we were looking at problems A through E, what transformations could be used to go from triangle 1 to triangle 2? So in triangle 1 here, what would it take? Would it take the we've got the three, you've got the rotation, translation, or reflection. And all that means is if you're going to rotate it or slide it or reflect it. So if we look at, and let's bring over a couple of these examples. Well, let's use these two pieces here, and I'm going to bring those over to this other page so that we can manipulate those on this page as well. But what do you think it takes to do this set here from triangle 1 to triangle 2? Is it merely a rotation? Is it translation? Or is it the last one, reflection? Or is it a combination? It could be rotation and translation, or it could be rotation and then reflection, or maybe it's just translation, or maybe it's just reflection. It could be a combination of any of these three, but what would it take to go from triangle 1 to triangle 2? If you said reflection, you were correct. In this one, all you would have to do, if you notice this point right here, is the equidistant from this point. And this is the same point right here. So all it is a mirror reflection. This is like the mirror right here. So the mirror is right here in the middle, and we mirrored that to reflect it. What about B, to go from triangle 1 to triangle 2? What would that take? All right, if you said translation in this one, you were correct. So just to go from here to here just requires a simple slide. If I was to slide this one straight over, it would go into that position. What about triangle 1 here to triangle 2 on letter C? If you said rotation, you are correct. Rotation, in this case, it'd be very much like this if it was in this position right here, and then we were to rotate that. It's similar to that, exactly what you see there. So you see that to go from triangle 1 to triangle 2, it's like rotation. Okay, on letter D, what does it require here to get from triangle 1 to triangle 2? So if we were going to go from this triangle, and then we were going to make it into this triangle to make it exactly on top of it, what would that take? If you said that in this one, for letter D, you could say that it's 2 parts. So you'd have to, it requires 2 things. It requires translation, but it also requires and reflection. In this case, if you were to slide this particular triangle over, if you just, all you did was slide it, you see it doesn't work. If we slid it this far though, and then we recognized, oh, we can reflect it, this piece would match right up to that piece, that point, that vertex. Okay, what about letter E? What would it take to go from triangle 1 to triangle 2? Now, some of you might have said that it's just simply reflection because you're like, well, here's the line, but that doesn't work. This is not a line. It has to be a line like this right here. It have to be reflecting on something like this, but it can't be reflecting on a simple point. So in this case, we'd actually have to rotate it. There's 2 parts to it. We would have to rotate, rotation, and then in that, after you're done rotating it, you'd have to do some reflection. Let's see if we can duplicate that on these here. Let's say if we rotate this, this would be very similar to this piece right here. And then let me bring this over here. It'd be very similar to that. And if you were to rotate this, you would get it to a point similar to this. So here I just rotated it, and technically I slid it too, but all it would require is some rotation. And in this case, we were actually going to rotate it until we got it lined up. Like, because it's got that point right there, we'd probably rotate it to this point. So we have that same point still there. Now we reflect on this line right here. So it took 2 moves, rotation and reflection. All right, what about this last one, letter F? It says in this case, it's a little bit different. it's asking this question. Write the coordinates of the vertices of A, B, C, and the coordinates of the vertices of its reflection, prime A, prime B, and prime C. So in this case, all you have to do is look at the coordinates for A. So A is at, looks like it's a -2, 4. So that's -2, +4. B is at -1, +1. C is at -1, 2, 3, 4. So it's a -4. And it's at a +2. Now what would it be for the A prime, the B prime, and the C prime? You guys go ahead and answer those right now. For A prime, you should have gotten 2, 4. For B prime, you should have gotten 1, 1. And for C prime, you should have gotten 4, 2. All right, and that is transformations in a nutshell. If you can please answer that, you need to name the transformations necessary to get from position 1 into position 2, or triangle 2 in this case. So remember, number 2 is over here. From here to here, what would it take? What movements does it require? Same with number 3 and number 4. Try to answer that and get it done before midnight tonight, and we will see you guys tomorrow.